Hello, in this video we're going to go ahead and walk through using hidden gems to see relationships in your data. I'm working off of our online edition, so this is hiddengemsml.com, and I'm going to go ahead and get started. Now, the first thing that we'll see is that there's a variety of sources you can use for retrieving the data to analyze. So you might have a CSV, comma separated value, or TSV file on your machine. You might have an online CSV file or a public Google Sheet spreadsheet. Any of these are valid options. And the idea is, if you have any data in Excel or in an application that exports to CSV, then it's something you could use with Hidden Gems. Now I've got a sample file here for convenience. If we bring this up, so what I've got is a CSV file, and I've got 5 columns here. The first one is asking, should I or shouldn't I buy a particular car? The next column shows us the age of that vehicle. Then we've got how many repairs and cost-wise have been done over time. What's the Kelley Blue Book rating of that vehicle, and what's the crash rating? And then we've got the data. And you'll notice that, this data isn't perfect. I've got things missing. Hidden Gems won't care about that. It'll do the best it can with what you have. So what I'm going to do is I'm going to go ahead and click Try with Sample File. And now Hidden Gems is going to parse out that file and process it to give us the columns that are eligible for analysis. So in this case, we've got all 5 because they all happen to be numeric. That's one of the requirements, is that Hidden Gems will only allow you to identify relationships for a numeric or true-false column. So one of the two. Now I'm going to go ahead and choose a column that I want to sort of predict the value for and see the relationship. So should I or shouldn't I buy the car? A yes or no value in this case. And then I click Start Digging. So at this point, Hidden Gems is going to do a lot of stuff. And in the next video, we're going to talk about the particulars of what it's doing. But in short, it's doing a complex computation in the background to help us see the relationships in the data. And when it completes, it's going to present for us a simplified view of that relationship. So what we see here is it asks, what column contributed most to should I buy the car? And if we go, yeah, that's fine. And then it says bigger and clearer words mattered more. So in this case, what we see is that the car age column is the most clear and largest column of all the ones that were identified. In this case, there were 3. So here we've got total previous repairs and Kelley Blue Book rating. What this tells us is that for that column, should I buy the car age was the most significant contributor to whether or not the decision was made to purchase the vehicle. That's what this tells us. In simple terms, car age mattered most. Now, what I do with this information from here is up to me. I've gotten this additional perspective from Hidden Gems, and then I can go and I can say, okay, well, let's take a look at some trends. Let's evaluate, different ages of vehicles and what mattered most. So if I go in, this day is a little bit hard to read, but a 100-year-old vehicle we didn't buy. A 2-year-old vehicle we did. 3-year-old vehicle we did. A 98-year-old vehicle we didn't. So the data is pretty clear in this case that the car age flipped the switch between whether or not we purchased the vehicle. So that's it. That's how to use Hidden Gems. There's 3 steps. The first is, if we go in here, we get started, we choose a file, or we try with a sample file. Then we choose our column that we want to analyze. And then Hidden Gems does all the rest and gives us a result. Now, one thing I'd like to note, there's 2 items of interest. The first is Hidden Gems may not find any relationships. It's not unexpected that in some cases there aren't any mathematically identifiable relationships in your data. The other is that the result isn't always the same. Because of the way that Hidden Gems does its analysis, it may come to a different result when you give it the same data twice, because it may land on what it finds as a preferable outcome of the analysis it's doing. In this case, what we see is it actually, depending on the algorithm that it landed on, the car age was even more significant. This is about double the size of what it was previously. So depending on the situation, or depending on how it proceeds in the given time constraints that I've restricted it to, you may find more or less the same result, but it won't always be identical. I wanted to note that. So in the next video, we're going to talk about the particulars of how Hidden Gems works. We're going to get into the nuts and bolts. Thank you for your time.